we need continual learning, where this is coming from, and we'll also describe a pipeline, an end-to-end pipeline of machine learning that is including also AutoML, model deployment, and model monitoring. And then we'll summarize, and we'll also have some more time for Q&A. All right, so what is continual learning? So continual learning is basically is the ability of a model to learn continuously from stream of data, new data that is coming into production, and use that data to retrain the model, to make that model active and fresh and relevant to the new data that's coming into production. A pipeline of continual learning is basically getting data, doing some data quality tests, data validation. We also do AutoML and hyperparameter optimization. When we talk about continuous training, we also do model validation, then model deployment, and then we're going to take those predictions and we're going to monitor our models in production, and we're going to reuse those predictions for retraining the model. So why do we need continual learning? The main reason is simply because data is changing. The models that you have today will not be as good as the model that you probably need tomorrow. Classic example is Amazon bestsellers. 10 years ago was Harry Potter. Today it's like a completely different book. And it's very important for companies like Amazon, e-commerce websites, and basically almost any model that you put in production to retrain that model on new data so it will be relevant to the buyers today, to the users today. So that's a great example of why would you need to retrain a model continuously. All right, so in this webinar, we're not going to cover the entire steps, all the steps of a continual learning pipeline, but we are going to talk about AutoML in the scope of continuous training. It's a critical and very important part of the machine learning pipeline, also in production, and it's very exciting also to build this kind of component in your production pipelines. We're also going to talk about model deployment. So when you have a new model generated from the AutoML process, how do you safely deploy that to production? And then we're going to also talk about monitoring, like identifying changes in data in production, identifying model decay, data shift, and a lot of other cool stuff. During this webinar, if you guys have any questions, then please feel free to ask. All right, so we'll start with AutoML. So why do you need AutoML? So basically data, think of our production as a pipeline that you get data. It doesn't matter where you get the data from yet, but eventually you get data that like every day, every hour, it doesn't really matter. And you need to retrain the models that you have to make them relevant for the data of tomorrow. Meaning that if your data is changing and your daily data is not the same as the data you might have tomorrow, then the models will also change. Meaning that what we're gonna show you here is basically that you get data and then you're gonna run a bunch of different algorithms on those on the new data. It could be if it's a classification task, then it could be SVM, it could be logistic regression, it could be also random forest and XGBoost. And if it's on like a computer vision side, so it can be different like transfer learning networks like VGG and ResNet and Inception and a bunch of other stuff. Also for each algorithm, you have multiple hyperparameters. So inside the AutoML component, you need to keep that in mind, thinking how you can basically set a space of values that you want to explore for every new model that you build, and make it like efficient, make it running in scale. And this is also why we're going to use Kubernetes.
Do you want to take a moment to ask a question?
Yeah.
So I'm going to read the question. from Robin B. How do you know whether the continuous stream of new data is good knowledge you want the model to use or bad knowledge to be excluded? Doesn't human domain intelligence need to be applied?
Yeah, so that's a really good question. What's happening is that there are a lot of tasks in machine learning that you don't need to have human in the loop. For example, recommender systems, you might have like an ETL process, an extract, transfer, and load process that basically takes the predictions and takes the input data and check it the day later with like the ground truth. There are also a lot of use cases where you will need a human in the loop, and this is why we also have this component here, cleaning and labeling, and this process may trigger like a labeling task or a cleaning task that needs a human to do that manually. All right. Okay. All right. So one thing is when you're building an AutoML in your continuous training pipeline, think that for every new data set, data version, you'll need to retrain the model. This means that you're gonna run a lot of experiments, a lot of different training with different algorithms, with different hyperparameters, and this creates two main challenges. First of all, scaling. So you need to run a lot of experiments in a very short period of time. And to do that, we're going to use Kubernetes. With Kubernetes, you can basically orchestrate a lot of experiments, a lot of jobs in your cluster, in the cloud, could be on-premise also, and then really save a lot of time. It's basically going to parallelize your work. You know, you can also integrate it with an open source hyperparameter optimization tool, and then take the best model and put it in production. Now, another very important thing is about tracking your models. So think that you have a model, a pipeline that is retraining every week. This may could be very quickly turned into like hundreds of models where you want to track. You want to make sure that the models that are in production have really good accuracy, and you want to understand what kind of model, what algorithm was used in the production environment. So we really recommend that you track your models. Like when you're designing this AutoML component, you should keep in mind tracking results. There are open source tools to that. To do that in Converge, it's automated, so Converge will automatically track all the hyperparameters, all the metrics, and giving you like an easy way to compare the different models and to visualize everything. And if you're building your own pipeline, this could be critical. All right. Okay. Next is about model deployment. So we basically have our data. We did the data validation. We trained a bunch of like, let's say 20 different models. We have one that is the best, that passed model validation. And now we want to deploy it to our production. So when you deploy new models to production, that's pretty dangerous. Like it's not just like software, because there is some unknown stuff in machine learning. So to really minimize the risk, you have to run a lot of tests and to make sure that your models that was trained is tested and is ready for production. So you should, we recommend using a canary deployment technique, which basically really reduces the risk of deployment. It will gradually deploy the new model, first, let's say, on 20% of the traffic, and then will gradually increase the network, so it will basically take over the endpoint. Now, if something bad is happening, during the model deployment, it will roll back to the previous model, the model that was good, that was working well in production. So we really recommend using canary deployment, canary release. It's a term came from software development and can be also used in machine learning. To build this kind of pipeline, and also canary release mechanism, use Kubernetes. Like, it's definitely Kubernetes is going to be the go-to for IT. It's something that IT and DevOps enjoy working with, and it's really scalable and it has a lot of really good potential for machine learning. So we recommend using this as an infrastructure solution. And also another project, open source project, is Istio. Istio is a service mesh designed for Kubernetes that allows you to run those kind of A/B tests and traffic routing and stuff like that. We have a guide of how to set it up in your own environment, so we'll send a link to it when this webinar is over. Okay. Once we have our model deployed, so again, we have our data, it's been validated, and then we built an AutoML component that trained 20 different models. It then picked the best one, got one champion model, and deployed it to production. Now, what we're going to do is, besides the fact that we might get new data to trigger model deployment, we can also trigger based on model behavior in production. Why would we need that? Because sometimes when you get like unexpected value in production, like unexpected prediction, or the correlation of the production data is not correlated to the training data. And this could mean that your models in production are not relevant. Like, the model in production is not relevant, and you should retrain the model on different data. Those kind of things is like a monitoring level for machine learning. There are also, of course, monitoring for DevOps, like system health and CPU and memory and stuff like that. But when we talk about monitoring, we talk about the machine learning monitoring, how you can make sure that your models in production are healthy and working well. So besides monitoring input data, you can also monitor the prediction itself. So we can monitor the model confidence to make sure that the prediction is in high confidence. You can also monitor model bias and other different metrics that, as a data scientist, you can add on your own. Also, when you build this kind of solution, this kind of architecture, some of you probably data scientists and some of you are data engineers. So when you design this kind of architecture and solution, you have to make it really easy for other data scientists to simply be able to add new validations on the fly. Meaning, I'm a data scientist, I have a new rule that I want to add, a new metric that I want to measure. It needs to be very easy for me to add it and to make sure that my models are healthy.
I have a few questions.
Sure.
So George from Everyman's AI asks, I thought a trained model can generalize, so if book ranking heuristics is captured in the trained model, why retrain it? The model has learned how to use input data to generate the resulting ranking. If another Amazon book becomes more popular, then the trained model should be able to determine based on the features it was trained on and that another book is more popular. Please explain.
Yeah. Cool. So it's a great question. So the thing is that models are very sensitive to the data that they were trained on. So a model that was trained on data that didn't have, like, for example, the new book, it won't know the new book, therefore it won't be able to recommend it. So to make your models fresh, you have to retrain them on all the data that you have. And if it means that there is new data added or old data removed, you need to make sure that the model that you have in production is trained on either. All right. Okay. So next is like also in the monitoring, there are a lot of tools that offer that. Open source tools like Prometheus and Kubernetes with the alert manager. Also, there is a link here of how to set it up on your own. It's great tools, very engineering heavy, hardcore. So for the data scientists out there, it might be a bit hard, but it's great. It's production ready, and we recommend it. At Converge, we made it simpler for data scientists to add new alerts. So you can basically monitor input data or the prediction, and you can simply add rules and conditions of if your input data is facing unexpected values or the prediction itself, the model confidence is below 0.5, then send an email to myself. Or if the model confidence is indeed below 0.5 with very high sensitivity, then run a flow. And this means that Converge basically in this use case, whenever the model confidence drops below 0.5, it will automatically retrain the model. And in the retraining pipeline, it will basically get the new data, train it on a bunch of different algorithms, and then update the model in production. All right, so based on monitoring, you can also add triggers, and it doesn't need to be also just on monitoring. It could be basically you can retrain a model periodically. Let's say it's a recommender system, for example, that you know it has to be updated every day. We also saw teams who were working with teams that retrain their models every 30 minutes to make the models really updated. So you can set the training based on a periodic system. And you can also retrain a model based on new data that is coming in. So for example, if a new data set, like a bulk of new data has been added to your S3 bucket or to your object store or something like that, you can trigger training automatically based on that. And the last thing is exactly what we talked about. Like if the model decays or suddenly there is a model bias or any kind of alert in production, you can also trigger training based on that. Now, when you retrain in an automated way, you have to make sure that you track and monitor everything. So you track the model training, you also track the model validation and the predictions, and also the model in production. So having this kind of knowledge and database of exactly what happens in your models in production and also in training is critical. So you will know exactly like what model is in production and why.
Mind if we stop for a few questions?
Sure.
So I'll start with one that was, I think, in the previous slide. How can these conditions integrate with our own code?
So it's a great question. We'll show you a demo in a second. But basically every condition here represents a code snippet that is being injected to the server automatically. So you can add new rules on the fly, and it's your own code. So you can basically create your own conditions.
Another question is, does your implementation of AutoML support universal transformer architectures for sequence problems? Also, how are you handling transfer learning in the context of model management?
Great. So also a really good question. So in Converge, what we do is we don't really create an AutoML out of the box. We help you as a data scientist, as a data engineer, to create your own custom AutoML solution. Now, it could be any kind of algorithm. It could be for sequence problems. It could be for images. It could be for videos. It could be really anything that you want. We provide you the framework and the infrastructure to basically build your own custom AutoML. For model management in transfer learning, so everything that you do in Converge is automatically tracked. So even for transfer learning, you know exactly like what was the base model, how did you train the last layers, what were the hyperparameter, learning rate, and stuff like that. And you know exactly like what is the model that was created from that transfer learning algorithm. All right. So let's now simply go over the platform and a real use case. So this is basically Converge. When we talk about Converge, we sort of like compare it to Git, but for data science. We help data scientists to really create like a single platform for the entire work, both on the research side and also for production. So we'll go into an example project. We'll use MNIST as an example of how you build your own custom auto-adaptive pipeline in production. So this is the project home. You can see I have here my files, and this is the MNIST code. It's directly from TensorFlow Keras website, and there's no, like in Converge, you don't need to add any dependency to your code. And then we're going to use flows. Flows in Converge is basically the ability to design a production-ready data science pipeline. So here we're going to simply use the dataset, the MNIST dataset. And now we're going to use a bunch of different algorithms. So here you see I have, this is what we call in Converge the AI library. There are a bunch of different algorithms. In our case, this is exactly transfer learning. So you can see this is the script that it's going to run. It's Python script. And those are the hyperparameters that this script receives. Now, you see here I have epochs and I have learning rate. There are obviously a lot more. This is just an example. So here, I have comma-separated values. This means that Converge will automatically test all the different permutations in one click. That's pretty powerful because every permutation of this is running on an isolated compute. It could be my GPU on AWS. It could be my Kubernetes cluster. It could be anything that I want. But ResNet is a great model for transfer learning, but we're also going to use VGG. And we're also going to add our own model. So we are data scientists ourselves. We know that it's important to keep everything flexible, so we wanted to make it really easy for other data scientists to simply use their own code. So you can simply type in the command that you want to run. Here you can name this model, and then you click Save. So here I'm using PyTorch, Keras, and then another PyTorch implementation. And then I'm going to add my own custom validation rule. Again, it's a Python code. And at the last step, I'm going to deploy the best model. Now, what happened here is basically just like what we discussed in the slides. We're loading data. We're now passing it through 3 different algorithms with 3 different hyperparameters. We're going to do a validation step, and then we're going to deploy it to a web service. Now, once I click Run, Converge will automatically run all those experiments on Kubernetes cluster, and everything will get tracked automatically. So I have this experiments tab, and every model that I create here is automatically tracked. So I can see exactly what happened in each model. I can see resource usage, I can see hyperparameters, metrics, and I can also see the output of the experiment and everything, all the artifacts that were created. I can then even create like a dashboard of the latest models that were created, click compare, and I see everything side by side. Now, in terms of serving, so this is the last step of the model deployment. So we allow data scientists to simply publish their models as a web service through this UI, and then the model is accessible through this REST API. And like beside the fact that we reduce model deployment to just one click, we allow data scientists to simply see all the output and all the input of the model. You can really monitor all the predictions, you can get all the input and all the output. We also have Grafana and Prometheus already built in on the cluster, so IT people love this, the fact that they can track CPU and resources. And we also have A/B testing capability and auto-scale. And the last step is continuous learning. So we allow data scientists to basically set up alerts that, for example, like I showed earlier, you get, if the input data is you get unexpected values with medium sensitivity, then email the data scientist. And the same I can do for the prediction. So if the prediction, if a model confidence is below 0.5, for example, or I can just add my own code with really high sensitivity, then rerun the flow that we just built here. And this is basically closing the loop. So I have a pipeline that is using AutoML and validates my AutoML to deploy it to production. And in production, I have alerts and monitoring, so I can make sure that my model is production grade ready. I'll go back to the slide. Before that, do we have?
Yeah, we have another question. Does your data set need to be static, or can you stream data via Kafka?
Cool. So that's a great question. We get that a lot from customers and prospects. We allow in Converge, you can basically connect any data source. It could be an S3 bucket, it could be any kind of object store. And it can also be Snowflake and Kafka and other streaming services.
We have another question.
Cool.
You want to go over it in the time?
Yeah, we can go.
Okay. For production purposes, one question, what is the largest, say, deep learning production model you've been able to support using your framework? Mm-hmm. Should I continue with the other question?
No, it's great. So basically for this question, we have teams that train models on like dozens of GPUs. We have autonomous driving application running on Converge, and I don't know like exact numbers, but it's really large scale.
Another question that this person had, what happens when the model breaks in production because it is either ill-specified or because you have runaway processes on overloaded architecture? How do you handle process exceptions? And do you have the ability to kill processes, etc., in real time?
Mm-hmm. So basically, one of the ways Converge is really like production ready is because we really embraced Kubernetes, and we're like supporting Kubernetes in a native way. And we also added a bunch of other stuff on top of it. So first of all, you can always run tests on your model in production, and also during deployment and also after deployment. So if something is happening to your models, you will automatically get alert, and you can also trigger actions based on that. Like you can set a webhook, you can scale the cluster up and down based on alerts, and you can also run retraining like we just saw. Everything is to ensure that you have high availability, high uptime, and that your models are healthy.
And a third question, is the process manager kept separate from the underlying process themselves, or are there dependencies that would be created which might act as vulnerabilities during runtime?
Yeah. So also a great question. So when we started to build Converge, we designed it in a way that in Converge you can basically have Converge installed on like a VM or something, and then you can attach different compute resources to it. So Converge sort of like acts as the process manager, and it runs processes and jobs and training and serving on different compute resources. This is great for IT people that want to manage their compute separately, and also allows you the flexibility to use basically any cloud account that you have, any Kubernetes cluster, and really make everything separated and scalable.
Great.
All right. So to summarize, continuous learning is definitely the future of your machine learning models. We see this, we see the demand for this kind of architecture, this kind of solution, both for like production and also teams that are doing research on it. It's really increasing, and it's definitely making models better and providing much better results. Another important point is that continuous learning is doable. Like, it's not hard. It does require some engineering and some data science work, but it definitely worth the investment. Having an autonomous machine learning pipeline in production is awesome. Something that you do need to keep in mind that you have to add tests in every stage of the pipeline. Having this autonomous pipeline is cool, but you have to test every step of the way. Data, AutoML, testing, and deployment. Also, you need to track everything so you know exactly what kind of models you have in production today and what model you had last week. It's critical. And also that kind of data is priceless, because then you'll be able to know what kind of models working best on your data and sort of like build your own meta learning pipeline. If you're building it on your own, then you have to think of the two personas that are using this kind of solution. It's both science, both like data science, machine learning developers, but also engineers. Like, engineers need to be able to monitor production. They need to be able to alert and to retrain models, and the data scientists need to be able to add their own secret sauce and just like do their magic. We recommend reading Continuous Learning in Practice. It's a great paper, and we're going to also share a link to it